Now that we've seen the Galileo in action, let's take just a minute more to examine the report that is generated. Here we see an example of a standard report. Let's break it down into some subsections. At the top, we see the patient identifier, followed by the functional level output measures, and lastly, the actual recorded daily step activity. The horizontal color bars represent predetermined activity levels, low, moderate, and high, while the vertical black lines represent the actual numbers of steps taken in 1-minute increments. On the Galileo report, the statistic reported for each descriptor represents how this client, at this time, matches up versus ADL ambulation requirements and the activity of other clients in our database. Note that it is normal for a client to score higher in some categories than others, and each of the 4 descriptors get an equal vote as to the ultimate reported functional level. This does not penalize someone for their particular gait requirements. For instance, variability scores equally with ambulation requirement. Also, the measures are continuous variables. That is, the Galileo calculates how each statistic maps to the functional level within a 10th increment. This gives the measure much more sensitivity to the condition and change of the patient. A patient with a measure of 2.7 could really be a patient who is a 2 rising to a 3 or a 3 falling. It makes objective statistical sense to round up when considering the reported K level. First, let's look at cadence variability. Cadence variability reflects the variation in the amount of time that the client spends at 3 functional levels of step rate, 0 to 15 steps per minute, 15 to 40, and 40 and above 40. These rates are then mapped to a database of representative activities conducted by prosthesis users. Here's an example of high cadence variability. In the enlarged portion, we see that the patient exhibits all 3 levels of step rates and has several transitions. Additionally, they participate in activities requiring both sustained rates as well as rapid changes. The potential to ambulate captures the peak burst of activity over the course of a week by searching the 24-hour, 7-day-a-week recording of the stepwatch. The system will detect activities even for a few seconds during the week. This is analyzed to show potential, even if not sustained. This does not work if the person is completely unable to ambulate at the time, but is very effective with patients returning to function. Now let's look at an example of peak potential to ambulate. Here we see that even though the patient frequently engages in high activity, their true potential is defined over a 1-minute segment during the week. It is these bursts of activity that are often missed during self-reporting and clinical observation. Ambulation requirement looks at the maximum number of steps the person will take with their prosthesis during a 20-minute window whenever it occurs throughout the day. The amount they sustain use of their prosthesis is a good indicator of whatever they have need to transfer, ambulate in the home, ambulate in the community, or have needs in excess of ADL. This range of functional requirements match nicely to functional level definitions. Lastly, here we have an example of ambulation requirement. Clearly, the patient is able to ambulate at high rates for extended periods of time. The Galileo system brings a level of science to the determination of patients' clinical outcomes. Thank you very much for attending today.